Hello everyone, hope you all are doing well. So now we will start our next topic, that is second and third law of motion. Today we will discuss both law. So talking about second law of motion is also called the law of acceleration. Is also called the law of acceleration. Second point, that when unbalanced force act upon a body, the body is accelerated in the direction of force. Like we are having here any object, okay, that on that we put the force over here and it move forward to accelerate. So it says that when unbalanced force, it's not a balanced force, unbalanced force, it acts upon a body and body is accelerated in a direction, is called in the direction of the force, is called second law of motion. After that is the first one. Here this is our first one equation. This is our first one equation, that A is directly proportional to F. Okay. Now let's move to second one. It says that acceleration is inversely proportional to the mass. How acceleration is inversely proportional to the mass? Why not force is inversely proportional to the mass? In the relationship of the second law of motion, acceleration on the body in the direction of force is accelerated, and also acceleration is inversely proportional. Like we put the force over here, that is F. It's the body, it's a mass M, it's accelerated. Now this mass is inversely proportional to this acceleration, because this force on a balanced force put it on a mass. We don't know what the mass is, so it's inverted, means inverted to the acceleration. When it inverted, so acceleration is produced. So that's why acceleration is inversely proportional to its force. Sorry, not its force, its mass. Let's move further. So here second equation is also proof that A is inversely proportional to 1 upon m, means A is inversely proportional to mass. After that we combine equation 1 and equation 2 together. Okay, so we write over here that A is directly proportional to F and inversely proportional to m. When we will remove this one directly proportional sign, we are having K, and K is a constant. So there are the two K, one is temporary and the one is constant K. So we are using here temporary K value, that is K is equal to 1. When we put 1 over here, so it will multiply with complete value, and it is A is equal to F upon m. And this is a relation of second motion. What it is a relation of second motion, that acceleration is directly proportional to force. The body accelerated because force put it on it, and inversely proportional to mass, because mass revolved, then acceleration produced. After that, here we are having formula that F is equal to ma. F is equal to ma, like m is dividing over here, when it's moved there it's multiply, so F is equal to ma. The this is we can say the formula to find the force. Move towards to the SI unit of it. Talking about its SI unit is Newton. How its SI unit is Newton? Because we are finding from the formula, like the formula of mass is kilogram and acceleration is meter per second square. So 1 kilogram 1 meter per 1 second square is equal to Newton. So we can say that SI unit of force is Newton. Talking about its examples, these examples are the cycling and a hockey player hit a ball. How cycling? Like one man is cycling and he is pedaling the cycle. He is putting the force, okay, so he is accelerated more, okay, with the mass. Now there's a one more question, that like he is putting a low force, so having more acceleration. But one thing more, that whenever we are having more force, so we are having low acceleration. Not low acceleration, how much force we are having, how much acceleration that is. We will put the low force, we are having low acceleration, but it's in a single manner, like on a cycle. Just let me show you. Just wait for a while. Yeah, now Now let's see on a cycle, one person is sitting over here. He is pedaling the cycle and he is just moving in, enjoying. Okay, when we ask one healthy person to sit at the back, he asked him to, I want to also go to market, can you take with me? He said okay, sit at the back. When he is sitting at the back, in that one position, he is putting more force but low acceleration. So these are the two positions of law of acceleration. Talking about a hockey player hit a ball, like this is a hockey, this is a ball. Okay, now what happens that when he hit the ball on hit a hockey on a ball, he put it force and then it's accelerated on that much force. In how much action he produce a force, that much action it taking to accelerate the body. Okay, hope you understand the second law of motion. Move towards the third law of motion. Third law of motion, there are the three main kinds. One is the law of action and reaction. Third law of motion is also called law of action and reaction. Like one person throw a ball, you put a bat over there, he did the action and you give the reaction. Okay, he just throw a ball to you and you just put a ball with a bat and it goes into the reaction. After that, move to next. It says that every action is always equal and opposite reaction. As I told you that law of action and reaction, I have given the example of cricket, or you can take out the example of ball. We are throwing the ball, it's giving us a reaction. After that, the definition of this third law of motion is a pair of two forces, not a one force, the two forces. One force is that acted by you and second force that is reacted by that object. So this is the third law of motion definition, a pair of two forces. Every action is equal to is always equal and opposite reaction. Talking about one more thing over here. Here is it in FA is equal to minus FB. Likewise, if we will be putting here a force in a positive side, so when it comes back it will be decreases. So minus, negative and positive means action in positive, reaction inversely negative. Examples are there that a book lying on a table. Now you will see that it's the example of the rest, first law of motion. But no, like on the table, this is a table, this is a book. Book is over here. Now when it's just lying on a table, so here is action over here, that it's due to gravity it's lying and the gravity give a reaction that it's on a table. So it simply give us a equal and opposite reaction with the action. Like walking. Now you can say that walking is just a motion, not at all. It's a third law of motion. We can say it's a second. It's just a first law of motion, that any thing that is going in a uniform velocity. But no, it's a third law of motion. How is the third law of motion? Let me give you an example of walking. Like we are walking on a one surface, and that surface is called Earth. Just take a huge example. Like this is the Earth, and we are revolving. We are just walking on a Earth. So Earth is giving us an action, like due to gravity we are walking, and we are giving it a reaction again. Means we are giving it a reaction that we are standing over there. Okay, move to the flying bird. Flying bird is an also example of law of action and reaction, third law of motion. How? Like flying bird, when he's flying his feathers, so he moves forward, like he is doing action, and with that one action he travel his just path, and he is giving a reaction. After that, talking about swimming, like when we are doing swimming, we are putting our hands at the back to put the water at the back. It's the action, and in reaction we move to the forward. So this is all about today. Thank you so much.